Greetings and welcome from A10 on today's tutorial how to upgrade ACOS running VRRP-A and aVCS. My name is Terry Jones and I am the systems engineer for A10 covering Southern California. I've created this training video to provide a tutorial on how to upgrade A10's ACOS platform when running both VRRP-A and VCS. This is one of the most often open support tickets I see in my region. I've created this video to help provide A10 customers with a visual of the process to help build confidence in upgrading production A10 devices without causing a traffic interruption. Many of you may already be familiar with VRRP-A and VCS features. However, when it comes to working on a device in a production environment, fear always sets in if you don't have full confidence in how to manipulate these features on demand. I'm going to demonstrate how to successfully perform a hitless upgrade in only a few minutes. Here is the outline for today's tutorial. I've built this tutorial to be a quick reference you can use before performing an upgrade. Just a little preparation on the front end always pays off. I'll provide the info to help get you started. Then we'll look at my lab setup and move on to the prep work to do before performing the upgrade. Once we've done this prep work, I'll perform the upgrade following the steps we built on in the tutorial. If all goes well, we'll have our devices upgraded in no time. I'm not going to cover failback. From my experience, when an upgrade fails, it's either because steps were missed in the upgrade process or there is a file transfer issue, in which either case the upgrade just fails and the devices continue to function with the existing code. Please contact A10 support for assistance should your devices fail during an upgrade. Here are a few things I like to do before I upgrade devices from any manufacturer. I ensure that I have a written document for upgrading or downgrading the device. Many companies require this type of control anyway, but at a minimum it ensures that a consistent method is followed, which should create consistent, successful results. Next, you should have already downloaded the latest ACOS version to a server capable of FTP, TFTP, or SSH. While this upgrade can be performed via the GUI, I believe it is more challenging as you'll have to jump around on different pages on each device's GUI, while an SSH session to each device provides a simple interface to enter the commands to perform the upgrade more efficiently. Next, know your upgrade path. If you are not already running ACOS version 4 something, then please consult the version release notes. There is an upgrade path required for customers running ACOS 2.7.2 or 2.7.1 code to get to ACOS 4. Lastly, know the architecture in which you're upgrading the ADCs. Most customer deployments are in 1R mode, so should an outage occur, generally only VIP services will be lost. Should the A10 device be inline and is the gateway for all traffic, then connectivity to all devices behind the A10s would be lost. Here's a simple diagram of my lab setup that we will be upgrading. I have my ADC set up in 1R mode, so should I have an issue, only my services VIPs would be down. I am going to have a client perform a constant ping to one of the external VIPs to ensure there is not a loss of service during the upgrade. The full procedure for upgrading is found in the version release notes under Upgrading to ACOS and the version release. I'll run through them real quick along with a few other things I like to do for safety. First thing we want to do is perform a system backup. If you already use a configuration management tool and have periodic backups, be sure to have a recent backup readily available when performing the upgrade. We will then save the current running configuration locally to the box. Be sure not to link this profile. Next, we'll check the device to see from which hard drive the system is booted. There are 2 SSD drives on all A10 devices. Generally, the system will be booting from the primary drive. Next, we'll run the show startup all command to see the profile that is currently linked to the active hard drive. After that, will back up both systems as well as get a show tech support output. Lastly, I have a few other commands I like to run just so I have the output readily available for quick verification check once the systems are upgraded and back to the original setup. If I were running OSPF or some other protocol, I would also run a few more commands on those features to ensure I have the output to reference. To determine the current version and the hard drive the ADC is currently active on, we need to look at the show boot image output. On the left, the output, we can see that we are running on the primary hard drive denoted by the asterisk, and it contains ACOS version 4.10-P5.135. We can also see from the output in the upper right that the configuration profile L2 DSR with the date is loaded to the primary drive. The question of should I upgrade both drives is a question I field a lot. The ADC has redundant SSD drives, so a good methodology to follow is to upgrade the primary drive with the new code, but have the current code in production running on the secondary drive to allow for quicker failback if needed. Ensure you link the startup configuration to the secondary drive, so if you fail back, then the production configuration will be loaded on reboot. You can link the configuration to the secondary drive by running the command link startup config profile secondary, assuming we're running on the primary drive. Consult the Systems Admin Guide for more information. VRRP-A is the ACOS implementation of Virtual Router Redundancy Protocol. For purposes of operational familiarity, it borrows some concepts from VRRP, but is significantly different. VRRP-A simplifies configuration of multi-system redundancy and allows up to 8 ACOS devices to serve as mutual backups for IP addresses. VRRP-A is supported only on ACOS devices that are deployed in gateway or one-arm mode. The output on the left shows my VRRP-A configuration. I am only using VRED 0, and under VRED 0 I have given each device a priority. The priority for device 1 is 160, while the priority for device 2 is 120. From the output at the right, you can see that it is indeed the case that device 1 state is active, while device 2 state is standby as anticipated. It is important to note that the default VRRP-A priority is 150. If you do not configure these stanzas explicitly, then the devices will use the default priority, which means that all systems will be 150. This also means that you cannot be sure which device will be VRRP-A active. If you run the command show running config with default VRRP-A as shown, you will see the output for the ACE device context with a default priority of 150 for those that have not been explicitly configured. I would recommend setting the priority explicitly to a value other than 150 to ensure that you are in control of the VRRP active device and can see the value in the configuration. ACOS's virtual chassis system enables you to manage a cluster of ACOS devices like a single virtual chassis. One ACOS device in the virtual chassis is the virtual master, called the vMaster. The other ACOS devices are virtual blades, also called vBlades, that are within the virtual chassis and are managed by the vMaster. As a controller for the vBlades, the vMaster provides centralized storage of the entire ACOS device configuration. Any configuration changes from the vMaster are automatically propagated to the vBlades. aVCS as a management tool provides high availability functionality on the ACOS device with the help of VRRP-A across multiple ACOS devices. The VCS configuration on the right shows that I have two devices, device context 1 and device context 2. Device 1 has a priority of 125, while device 2 has a priority of 120. I also have affinity configured. I'll discuss that in a bit. The master affinity to VRRP-A active enables the vMaster device in a virtual chassis to fail over when the active device in a VRRP-A VRID fails over to a standby device. When the standby device becomes active, it will also act as the vMaster device in the virtual chassis. I like this feature as it will ensure that if I'm using a floating IP for management, I will always access the vMaster and VRRP-A active device. It can get confusing when the VRRP active device and the VCS vMaster are on different devices. This is a purely optional command. Based on my testing, if using Affinity, the VCS vMaster switchover will occur within 1 minute after the VRRP-A active device changes. We'll note this in our demonstration. I think we are almost ready now. Just a couple of last minute notes. For the upgrade, I would recommend not using the management floating IP address. The floating IP is tied to the VCS vMaster, so when the VCS shifts to device 2, your SSH session will disconnect. You can easily reconnect, however, having a session to each device will make things easier. I will now go through all the steps I've outlined in the presentation, then I will perform the upgrade. Here is a cheat sheet for all the commands we'll be running to perform the upgrade. Please take these, update for your environment, and use them for your next upgrade. Okay, I think that's everything. Let's get started. Here you can see I have an SSH client with 3 sessions open. The first 2 are vThunder virtual machines, and the third is a client we will use to verify connectivity to the VIPs. I have a text file with all my commands already pre-staged. I'm just going to cut and paste the commands between the file and my devices. This will help make the upgrade faster, smoother, and more importantly, mistake-free. The first step is to save the current config to a profile that can be retrieved later if needed. Be sure not to link this profile. Next, we're going to run the commands so it will save our system state for easier rollback if needed. The tech support file takes a little time to create and export, so be patient. After the backup and tech support files have been saved, we'll run the last few informational commands. We can just copy and paste the commands in all at once, then copy the output to Notepad. I'm going to go silent until this stage is completed. Before making any changes to the devices, let's get the constant ping going. I'm going to use my www-vip virtual server as the test VIP. For proof, we are pinging the VIP for the VMs in which we are upgrading. I'll shut down this VIP and verify the ping stops. Obviously, you would never do this in production, but for the purposes of this video, I just want to show that we're going to have a hitless failover when VRRP-A cuts over to device 2. As we start our ping, we'll disable the VIP. You'll notice that the pings stop. Once re-enabled, the pings will continue again. Next, let's check the clock. It's 2:37 p.m. We'll check back when we're completed with the upgrade to see how long the total upgrade takes. The first change is to disable VCS on device 2. This will allow us to change the VRRP-A priority and cut the traffic over to device 2 while we upgrade device 1. With VCS disabled, you'll see the Affinity and vBlade words are now in our prompt are now gone. We can also check the Show VCS Summary output on both boxes to verify the cluster is broken. Next, we will make the VRRP-A priority higher on device 2. As soon as we do that, you'll see that the VRRP state of standby shown in the prompt will change to active immediately. Let's stop the pings real quick to see if there are any pings lost. I don't see any lost pings here. 59, 60, yep, everything looks good. This shows that there are no ping lost on the cutover of VRRP-A. Let's start the pings back up. We can also check the VRRP-A output to show that device 2 is now the active device and device 1 is now in standby. Next, we will need to upgrade device 1. Let's drop in the command and let the VM upgrade. Upgrade times will vary based on platforms. However, there will be an output session window to ensure that you see the upgrade is progressing. Once the upgrade is completed, we've told the device to reboot. Even though the upgrade and reboot only take a few minutes, I'm going to go ahead and skip ahead. Okay, device 1 is now rebooted. Let's log in and verify VCS status, VRRP, and then verify the version. Here we are still the vMaster for VCS, as well as standby for VRRP. Show boot image shows we have upgraded the primary drive, and the asterisk denotes that is now what we are running on. Device 1 looks good, so let's go back to device 2 and change the VRRP priority. I jumped ahead a few seconds here, but you can see that device 2 is now the standby device and device 1 is the active device. We can jump to the bottom and stop our constant pings, then check through to see if we lost any pings. I feel confident that we performed a hitless cutback, so let's move on. Our last step is just to reboot device 2. Be very sure not to save the configuration. Since we disabled VCS in the running configuration, if we save those configurations to the startup config, then when rebooted, device 2 would not have the configuration to rejoin the VCS cluster. We're pretty much done. That was it. Let's go back to the primary device and check Show VCS Summary. Once the secondary device reboots, it will rejoin the cluster. Since the code version must match the same code as running on the vMaster, the vMaster will upgrade the vBlade, then it will sync the configuration. When the secondary device rejoins the cluster, we can log back in and verify the device is also now running v01-p5. Since the upgrade and synchronization to device 2 will take a little bit, I'm going to go ahead and jump ahead in this video. Okay, we can now see that device 2 has rejoined the VCS cluster as a vBlade, so we'll go ahead and log in. Let's run a few commands like check the boot image. We can now see that device 2 is upgraded to 401p5. We'll also check the time, 2:46 p.m. We started at 2:37 p.m., so the upgrade took less than 10 minutes. I'll go ahead and run a few other commands here to kind of verify my state for both devices. But they're both upgraded to 410p5 and in the original state. I hope this demonstration gives you the understanding and confidence when performing your next upgrade. Thanks for being an A10 customer. We truly appreciate your business and look forward to serving you again soon. Thank you.